Right, so in this eighth lesson, I've made a conscious decision to omit this section. That's because I like to hope that you're able to apply logic to it. But I'm going to just briefly talk about this section, so in case it comes up in your exam. So factors affecting the choice of hardware. So in a typical exam question, you might be asked to consider what are some of the factors that might affect your choice of a particular, let's say, computer. So it will stand to reason that you would explain about the user experience, talking about how easy would it be for the user to use it, the performance factor that they require from it, availability in terms of how easily available is it, the particular device, and is it always going to be reliable. Accessibility, if the person has any disabilities or anything like that in terms of being able to use it. And then the needs of the user. Again, do they need to use it for graphical processing, in which case they might need a lot of processing power? Do they need to use it just for Word document, in which case they probably just need to type, so they wouldn't require as much processing power or likewise RAM. Compatibility, this is regarding how easy is it to be able to use with other devices. Cost, of course, how much money there is to spend on it. Efficiency, is it able to do what you need it to do without unnecessary overheads? And in terms of implementation, how easy is it to be able to bring it into your organization? For example, if we're migrating from an old system to a new one, is it something that's going to require additional training? Is it something that's going to require a specialist to come and set it up? Productivity, again, does it include productivity software such as spreadsheets, Word document, etc., to be able to do things that you want it to do? And does it include some security? Okay, so for example, firewalls, as well as being able to set up backups and such like. Okay, so yeah, these factors, hopefully you'll be able to generalize that in your exam, but I'm choosing to skip over that because I'm hopeful that you're able to make sensible application of that if it was to come up in your exam. Right, so the next section of our spec here is data storage and recovery. So we're going to now talk about the RAID system. Okay, so this lesson is going to be focusing on the RAID. Okay, so RAID stands for Redundant Array of Independent Disks, and as we noticed there, it's abbreviated to RAID. So in terms of RAID is used for additional storage. Okay, so RAID system uses additional disk drive to add data redundancy to the system. So what we mean by data redundancy is that if something is redundant, that means it's not been used. So that's why you might make someone redundant at work. Now, redundancy in terms of storage is the idea of having a backup, if you like, of the data, such that if there was an error, we have something to go back to. Now, there are different types or different levels of RAID, starting from RAID 0, and in your exam going down to RAID 6. Okay, so let's start then with RAID 0. Right, RAID 0 is really not fault tolerant. So that means the whole idea of, it goes against the purpose of why we go into RAID in the first place, because what we want to be able to do is have something to go back to if there was a fault. But RAID 0 is non-fault tolerant. Okay, that means if there was a fault, that the whole thing will still not be any good to us. But what it does provide us with is the idea that we can strip data, so we can spread the data across two separate disks. And so the benefit of that is that is of speed. So that means that we can have a disk controller that is going to be able to spread the data being written to two different disks. Okay, so the idea of that is that it gives us more places for the data to be stored as opposed to one. Okay, but unfortunately, if one of them gets damaged, then our data is rendered useless because part of the data that would have been on the one section would then be missing. Okay, so there is a video later that I'll point you to that will give you a little bit more, in fact not a little bit, makes it very clear. Right, RAID 1 is the next part, and RAID 1 uses what we know as mirroring. Okay, so it mirrors what's on one disk to the other disks. Okay, so effectively it creates an identical copy of the data on another disk, such that if the first disk was to fail, then the system can run off the redundant disk, so the one that's not being used on a regular basis. So the advantage is that no data is lost, and if the one disk fails, then we have the content on the other one. Then I'm skipping RAID 2, 3, and 4 because they have in general terms cover similar things, but in the book you're able to read the content of that. But the next significant one is RAID 5. Okay, so this does not use mirroring, same as RAID 0, and it uses stripping, again same as RAID 0. And the idea is that it splits the data across multiple disks. So this time around we will use more than 2 disks. We'll have to use at least 3 disks. Okay, because we have something known as a parity error correction, which helps us to be able to rebuild the data in the event of a data loss. So parity bits is the idea of adding one additional bit to your data, and when we say bit here, we're talking about bytes of storage. So we add in an additional bit, and that additional bit helps us to be able to recover our data should it get lost. And because of this additional parity bit that we're storing for each piece of data that we're storing, then what it means is that we're having to use up a lot more disk space for storing data. So a disadvantage of RAID 5 is that it uses a lot of space. But the advantage, however, is that it's fast and it stores large amounts of data. Okay, so here's a YouTube link here for you to be able to watch the video that I'm referring to, and the video is very detailed and it goes through what RAID 0, 1 and 5 as just been covered here is. Okay, so hopefully that will give you more information on RAID.